This video talks about molecules and ions in section 5 of chapter 2. We've already kind of been using some of this vocab in our discussions and from some of the videos we've watched, but now I kind of want to talk about them much more specifically in terms of discussing then ions and how we're going to form our molecules and ionic compounds. So a molecule is two or more atoms combined in a fixed ratio and a fixed arrangement. So molecules are under the category of a pure substance. And what it means by this fixed ratio is the ratio of our atoms can't change. So for example, if we're looking at water, water has 2 hydrogens for every 1 oxygen. If we change this ratio, if we say for every 2 hydrogens we're going to have 2 oxygens, this is not the same thing. Okay, these are 2 different molecules. They have to have a fixed ratio. So once we have defined what our ratio is, we have to keep it. If we change the ratio, then we change the substance. The fixed arrangement part is one that we haven't really talked about, but if we look at H2O and we think of our atoms as spheres, which works for us right now, we have oxygen in the center, so that's oxygen. Our hydrogens are on either side of it, okay, either side of the oxygen. This is the arrangement that water molecules take. If we were to say put the hydrogens next to each other and then the oxygen, okay, that isn't water, so that would be a different substance. Of our molecules, there are 7 diatomic molecules, and these are 7 elements that exist as molecules instead of individual atoms. So what that means is when we find these elements by themselves, so kind of isolated and just one type of atom, they don't just stay individual, they actually pair up with another one of themselves. So they form a molecule of 2 instead of, their individual atoms. So there are 7 of them. This is how I remember them, is that they form a 7 on the periodic table. So if we kind of have a 7 like this, we have nitrogen, oxygen, and fluorine. Then going down, we have fluorine, chlorine, bromine, and iodine. So if you look at them on the periodic table, they form a 7. For those of you who can count, you say that's only 6. Anytime that there's an exception to a rule, most often it is hydrogen. So when hydrogen is by itself, it forms H2. Nitrogen by itself is going to be N2. Oxygen, fluorine, chlorine, bromine, and iodine. So anytime that these elements are by themselves, okay, just that type of atom, no other element, no other type of atom around them, they're going to pair up with another one of their own. You need to know these 7. All right, so what happens when we don't have an atom? What happens when our atoms either lose or gain an electron? Then we form an ion. Okay, so atoms form ions once we change their number of electrons. Their number of protons stay the same because if we change the number of protons, we change the element. So protons are staying the same, but the electrons are changing. Cations, these are positively charged. So they are going to be the result from losing electrons. Anions are negatively charged, and they're the result of gaining electrons. So if we look at an example of a cation, we look at, say, a magnesium atom. We want to look at how many protons it has, so we consult a periodic table, and we notice that it has an atomic number of 12, so it has 12 protons. In the atom, atoms are always charge neutral, so they are going to have 12 electrons. When we form a magnesium ion, the number of protons, again, stays the same because if we change the number of protons, we change the element, and that's not what we're doing here. We're changing the charge on that element. So 12 protons. Magnesium actually loses 2 electrons, so it ends up with 10 electrons. And why it loses 2 over another number, we're actually going to get into when we talk about chapter 7, so stay tuned for that. So our overall charge then of our magnesium ion, we have to take our positive charge from our protons, and then we add that to however many negative charges we have, which is negative 10 from our 10 electrons. So overall we get a plus 2 charge. So the magnesium ion is going to be represented like this. And typically what we do is we put the numerical value of the charge first and then the positive or negative second, and that's to make it look different than an exponent. The name of cations, the name of this cation would just be magnesium ion. We're going to be talking about naming a lot, so let's write down our rules. So for cations, how we name them is the element name plus the word ion. If we look at an anion, let's look at the fluoride atom first. Its atomic number is 9, so it has 9 protons. And as an atom, it's going to have 9 electrons. If we look at the fluorine ion, still has 9 protons because we're still looking at fluorine. Fluorine gains 1 electron to have a total of 10 electrons. To determine its charge, we take our 9 protons, which have a plus 9 charge. We're going to add our 10 negative charges from the electrons. So we have a negative 1 charge left over. So our fluorine ion is F minus. And the name of this is fluoride ion. So anions get named slightly different in that their name is going to come from the start of their element name with the ending dropped and adding IDE and the word ion. You are going to need to know the charges that ions take on the periodic table. You're going to need to know all of the elements except for the transition metals. So majority of the periodic table, you're going to need to know what charge those elements take. How you figure out that is you want to look at figure 211, and it looks at the group that elements are in. And part of the wonders of the periodic table is that all of the elements in the same group are going to have the same charge. Okay, again, ignoring the transition metals. So group 1A, they have a positive 1 charge, and they're going to lose 1 electron. Group 2A is going to lose 2 electrons, so they'll have a plus 2. Group 3A loses 3 electrons for a plus 3 charge. Most things in group 4A, they actually don't form an ion readily. There are some exceptions to that, but the elements that we're primarily concerned with are silicon and carbon for this class, and they don't have a charge. Going down group 4A, you have germanium, which is a metalloid. We don't use germanium very often in examples because its chemistry is different than most everything else. Tin, Sn, and lead, Pb, they're actually considered transition metals, so we'll talk about them later in this chapter. So moving on, we have group 5A, so that's your nitrogen and phosphorus. Those gain 3 electrons, so they're going to have a negative 3 charge. Group 6A gains 2 electrons for negative 2. 7A, fluorine is an example of group 7A, has a negative 1 charge, gains 1 electron. And all the elements in group 8A, they are noble gases, so they are not going to lose or gain electrons. They are happy exactly where they are. So anything that's under group B, and we're going to include tin and lead, and they're in group 4A, but we're going to group them in with the group B metals. These charges that they take are varied. They don't have a specific charge. Some of them can take a +1, some of them can take a +3. So we don't have a general rule for them. So we'll talk about how we know what their charge is a little later. So go ahead and take some time, fill out this table here for practice. Go ahead and pause the video, and I will go through the answers once you have unpaused it. All right, sulfur as an atom here, because it does not have the word ion, is S. The atomic number is 16. In our symbol, if we're given a mass number, we want to include that, so the mass number gets put in the top left corner. The charge, because it's an atom, is 0. Number of protons is equal to the atomic number. Neutrons is our mass number minus the number of protons, which in this case is the same number. And because our charge is 0, we have the same number of electrons as protons. The sulfide ion is different. It is going to have a charge, a -2. So that goes as 2 negative in the top right-hand corner. Again, we're still looking at sulfur, so it has 16 as an atomic number and 16 protons. Same mass number, so it has 16 neutrons. It now has 2 additional electrons because it has a -2 charge, so it has 18 electrons. This next row here, we have protons of 38, so our atomic number is going to be 38. On the periodic table, 38 is strontium, which is Sr. We have the same number of protons as we do electrons, so our charge is 0. Our mass number is protons plus neutrons, which is 88, so we include the 88 here. On the ion here, I have been given a mass number, so I should include that there. Next one down here, we have atomic number of 17, which is chlorine. The -1 charge, so 1 minus. You can also leave off the 1, that's just fine. We will have a mass number of 38. Is that right? 17 plus 18. My mind just went completely blank. 7 plus 8 is 15, 35. There we go. So we have chlorine, 35 there. 17 protons, we have a -1 charge, so we have an additional electron, so we have 18 electrons. Down here, atomic number of 56. 56 is barium, which is Ba. Mass number 138. 2 plus charge, so we have 56 protons from the atomic number. We have a +2 charge, so we have 2 electrons lost, so we have 54 electrons. Our number of neutrons is our mass number minus our number of protons, so we have, 82?